Hi guys, welcome to another video. The topic for today is functions. Now with respect to our exam, it's a very simple topic, very interesting and also quite similar to the topic we did last time, that is sequence and series. Right? So when we learned generic sequences wherein we plug in values, generic sequences are very close to functions. Okay, most of the methods are same. So it's a very easy topic and something a continuation of what we have done. Alright, so without further ado, let's get into this. So when we talk about functions, a complex algebra expression, everything comes to our mind. Okay. However, again I'm telling you, it's a very simple topic. See, what comes to our mind is we say f of x is equal to say x square minus 1. Right. So anything related to f of x, g of x, h of x, right? All those things come into our mind and we say, okay, this is function. Right. Now majority of the times the way to solve the question is simply plug in values. Okay, for example, let's look at it. Say function is x square minus 1. Okay, what does this tell you? That my input is x. Okay, my input is x and the output is x square minus 1. Okay, my input is x and my output is x square minus 1. So when they ask or when we say what is f of 2, okay, what is f of 2? So in place of x, we have to substitute 2 and where? Everywhere, right? So we have 2 square minus 1. What will f of 2 become? It will simply become 2 square minus 1, right? Which is 3. Okay, 2 square minus 1, which is 3. Okay, does that make sense? Right? If it does, let's try. Say what is f of minus 3? That will simply become minus 3 square minus 1, which is 9 minus 1, which is 8. Moving on. See if we want to find f of y. Okay, so what is f of y? So again, nothing changes. The function remains the same, input remains the same, output remains the same. Instead of numbers, now I just have a variable, but I treat the function the same way, right? In place of x, again you substitute y. So f of y becomes y square minus 1, right? Similarly, if I have f of x plus 3, okay, if I have f of x plus 3, right? So that will become, again, in place of x, right? In place of x, just substitute x plus 3, right? So this will become x plus 3 the whole square minus 1, and then you can simplify it. X square plus 6x plus 9 minus 1, x square plus 6x plus 8. Okay, so the point being that in a function, right, if f of x is given to us, whatever is the input, doesn't matter what it is, positive number, negative number, fraction, variable, same variable, just keep substituting, right? Let's take another example, f of x square. What will be f of x square? So again, in place of x, you have to substitute x square. So that is x square whole square minus 1. That simply becomes x to the power 4 minus 1. Okay, so the idea is you just have to plug in. What do you plug in? The value. Okay, what do you plug in? The value that comes here. Okay, what do you substitute in place of x? Okay, alright, so that is a single variable function, right? What if we have two different functions? What do we do then? Say again, we have f of x as x square minus 1, and we have another function called g of x, okay, which is x plus 1. Okay, now what is f of 2? 2 square minus 1, 3. What is g of 2? G of 2 will be 2 plus 1, which is 3 again. Okay, now if I ask, like, I concatenate them. Okay, what does that mean? That if I ask what is f of g of 2, Okay, if we ask what is f of g of 2, okay, so what we do simply is we always solve inside out, right? The any which is the way we do a BODMAS question, we solve inside out. So first we will focus on finding g of 2. How do we find g of 2? Right, we have already found that. Put this 2 in place of x here, right? So we know g of 2 is 3. So this then changes to f of 3. The whole g of 2, right? The whole g of 2, the value 3 is here now in place of g of 2. So now the question changes to f of 3. How do we find f of 3? In the function fx, substitute 3. So that is 3 square minus 1, which is 8. Okay, so if you have a concatenating function which is f of g of 2, okay, what do? You always go inside out. So you solve the inside bracket first. Okay, so first we solve for g of 2, then whatever answer we get, we solve f of that. Okay, if you understand this, then please try g of f of 2. Right, please try g of f of 2. Right. Again, f of 2 will be, we already know it is 3. Right, f of 2 we already know is 3. The question will convert to g of 3. G of 3 is 3 plus 1, which is 4. Okay, g of 3 is 3 plus 1, which is 4. Okay, so I hope you understand this. Again, the idea is simply plug in values. Alright, now let's solve the same functions, but to say a little bit more theoretically. Again, the method won't change, we will plug in, but we are just, instead of putting numbers, we are just keeping it at variables. So say same function f of x is x square minus 1, g of x is x plus 1, right? Now if we want f of g of x, right? So what I do, in place of g of x, right, as I said, we solve inside out. So first I solve for g of x. What is g of x? It is x plus 1. So the question changes to f of x plus 1. Right? Question changes to f of x plus 1. Now how do I find f of x plus 1? In place of x, substitute x plus 1. So that is x plus 1 the whole square minus 1. Simplify, x square plus 2x. Plus 1 minus 1 will cancel out. Okay, so even if you want to solve theoretically, right, just do that. Right, let's try g of f of t. Okay, let's find g of f of t. Correct, we solve inside out. First we solve for f of t. So f of t is, right, f of t is t square minus 1. Right, f of t is t square minus 1. Now g of t square minus 1, this I will substitute here. So that is t square minus 1 plus 1, which is t square. Okay, that is t square minus 1 plus 1, that is t square. Okay, so I hope you understand how function of a function works. Okay, let's try one more thing, one interesting question. Say we have f of y. Okay, say we have f of y. No different functions, it's the same function which is done again and again. How do we solve this? Right, so first find f of y. Right, find f of y. So that will be y square minus 1. That will be y square minus 1. Right, now in place of x, again we will put y square minus 1. Right, now what will happen? right? This y square minus 1 will again go in place of x. So that will be y square minus 1 whole square minus 1. Okay, that will then become y square minus 1 whole square minus 1. So that is how we will find f of y. Okay, so point is, even if it is a function of a function, you just have to plug in again and again. That's it. If it is function of a function, plug in 2 times. If it is f of x, 3 times, right? And always start inside out. Okay, the easiest way to solve such questions is to go inside out. Okay, right? Alright. So these were single variable but separate functions, right? But what if we have 2 variable functions? Okay, again the method won't change, it will remain the same. Alright, say for example, if it is told that f of a comma b, okay, is a square minus ab, okay, and we have to find f of 2 comma 3. So that will be simply, again, it's just substitution. 2 will become a, 3 will become b. So that will become 2 square minus 2 into 3. 4 minus 6 minus 2. Right? If there are 2 variables, do not worry. Whichever value is coming in place of the first variable, substitute that. Variable 2, substitute that. Right? Say for example, we have f of x plus 2 comma x minus 1. Right? So again, do not worry. This will become a, this will become b. So that's simply x plus 2 the whole square minus x plus 2 times x minus 1. If you want to simplify, you can take x plus 2 common. X plus 2 minus x minus 1. Right? That becomes 3 times x plus 2. Right? That simply becomes 3 times x plus 2. So the way you saw, right, the way we did 2 variable, it can be 3 variable function, right? It's all the same. Single variable, 2 variable, they are all the same. All you have to do is plug in the values to solve and get the answers. Similarly, right, the same question can be asked in a different way. Okay, you can have characters. Okay, the same question can be asked in a different way. Okay, you can have characters given. Okay, what does that mean? See, instead of saying f of x is x square minus 1, what if I tell you that at the rate x means x square minus 1? Okay, so now the way we have f of 5 as 25 minus 1, 24, similarly at the rate 5 will be what? That will be 5 square minus 1, 24 again, right? Or at the rate, say at the rate 2 will be 2 square minus 1, which is 3, right? We have function of a function, so we can have at the rate 3. Okay. So again you solve inside out, so you solve at the rate 3 first, so you will have at the rate bracket 3 square minus 1, that will become at the rate 8. This will then become again 8 square minus 1, right? The answer becomes 63, right? The point being that it's not necessary that functions are always given in f of x, g of x, the normal way that we seem to know these functions or represent, right? They can be given in form of random characters. You can have at the rate, you can have hashtag, right? Say hashtag x is x plus 1, so hashtag 5 will become 5 plus 1, which is 6, right? Or hashtag at the rate 5, right? Hashtag at the rate 5, what will it be? Let's solve. Hashtag will remain as it is. At the rate 5 means 5 square minus 1, that becomes hashtag 24, right? Hashtag 24 is, from the definition, 24 plus 1, 25, right? So the same question can be asked using custom characters, right? So whenever you see any character, any random character given, don't be afraid of it. Okay, just tell yourself this is a function question. All you have to do is plug in to get the answer. Okay. Similarly, the same set of questions can be asked using definitions. Okay, it is not necessary that we'll give you only function or character and the right? Sometimes they can just give a standard definition, and again it's a function, you just solve the definition. So what do? You plug in the value in place of the definition. Okay, for example, if I say the let's define some term, say length. Okay, let's define a term, say length. Okay, the length of a number, right? The length of a number is defined as the length of a number is defined as 1 less than square of that number. Right? And again the question can be, what is the length of 5? Right? So here what has happened, it's again a function question only, but instead of giving a character or instead of writing f of x and all, we have just written a definition. So see, length of a number is defined as 1 less than square of the number. Okay, again as I said, just plug in, right? So what will be length of 5? So in place of number, let's just substitute 5. So length of 5, okay, I'm replacing number with 5. Length of 5 is defined as 1 less than square of 5. Okay, what will it be defined as? 1 less than square of 5. Okay, now just solve this. What is square of 5? 25. 1 less than that means 24. Okay, so the point being that it's not necessary that the function is always given in a simple form. It can be defined also, doesn't matter. Again, all you have to do is plug in values, right? And if you observe this, say let the number be x now. Okay, let's do a different length of number. Let the number be x, right? So say length of number L of x is defined as, means equal to 1 less than square of x. Now what am I doing? I am replacing the number by x, right? I am replacing number by x, right? So length of x becomes square of x minus 1. If you see, this is same as the previous function f of x, right? So the point is, the same function can be given to us in 3 different forms. They can directly write f of x is this, or they can give a custom character, like they can make a random @ hashtag pound, whatever they want, a character, or they can give to us in a definition form. Okay, you don't have to worry, you just plug in, right? If it is a function, directly plug in place of x. If it is a character, again plug the value in place of variable. If it is definition, plug the value in the definition itself. Okay, do not worry, just plug the value in the definition and you can continue to solve the question the way you do. Okay, moving on, what if we have step functions? Okay, functions with certain conditions. Okay, say for example, it's given that f of x is equal to 2 minus x when x is odd, and it is x plus 3 when x is even. Okay, so now you have definition of function of x is broken into 2 parts. If it is odd, it is this. If it is even, this. right? And then they ask what is f of 1 plus f of 2 plus f of 6. Okay, so again, don't worry, all you do is plug in, right? Now I know 1 is odd, right? I know 1 is odd, so this function, this definition will be applicable. 2 is even, so then this definition is applicable. 6 is also even, so second definition is available, applicable, right? So I just find by using the respective definition, right? F of x is 2 minus x, so if x is 1, which is odd, x will become 1, so this, friends, will become 2 minus 1. 2 is even, so this will become 2 plus 3. This is also even, this will become 6 plus 3, right? So that is 1 plus 5 plus 9, that's 15, right? It is 1 plus 5 plus 9, that is 15. Okay, so even if step functions are given where we have different definition or different values or expressions for x, right, do not worry, just apply the appropriate definition and solve for it. Okay, see, finally, right, finally, now as I told you, right, at the beginning, that see, this topic is very similar to the previous one we did when we learned generic sequences, right? See, what was a generic sequence? Say they give an is equal to an minus 1 plus n, right, or plus n square, right? Now similarly we can have functions as well. F of x is f of x minus 1 plus x square, no problem. The way we used to do this, same way we will do this, plug in values, right? Say the question says f of 1 is 1, right, and they ask find f of 2, right, find f of 2. So what do we do? See, we know 1, right, so we'll obviously find 2, right? Had the question mean find f of 5, don't directly put f of 5, first find f of 2, then f of 3, then f of 4, then f of 5. So how do I find f of 2? Plug it back in, so f of 2 in place of x put 2, right? So this 2 goes here, 2 goes here, and 2 goes here, right? So f of 2 becomes f of 2 minus 1 plus 2 square, which is f of 1 plus 4. Since f of 1 is 1, 1 plus 4, 5. Okay, so even if functions is given in a sequence form, right, or similar to a sequence that we have learned, do not worry, again the method will still remain that you plug in the values to solve. Okay, so in short guys, right, you I hope you are able to understand that, for most of the function questions all you have to do is plug in values, right? Now coming on to the next part, right, which is the only theoretical part that with respect to functions that will come in our exam, that is domain and range of a function. Okay, so there are two theoretical things that we need to learn. First is called domain of a function. Okay, domain of a function is very simple, right? It is the input, right? Domain is simply the input. Okay, the values of x that I can substitute, right, and still the function is valid, right? See, it's not as if that if function is given I can put whatever value I want and it will keep on working, right? The value of x, right, sometimes it's restricted, so we need to figure out what is those, like, or what are those restrictions. All right, so when I write f of x, the domain is basically telling me what are these, right, values of x that I can substitute, right? See, think of it like this. Say your function is like a machine, right? Say a microwave. What happens? You put your food in the microwave or anything in the microwave, it heats it up, but the microwave has certain restrictions, right? You can't put anything you want. Similarly, it's not necessary that every function, right, you can put all the values of x, you can put 1, 2, 10, whatever you want. There might be some restrictions. Okay, so we are trying to figure out what are those restrictions so that we can avoid those putting those values, and in short find the domain of X. Alright, so there are only two restrictions with respect to our exam. One is your generic, or with respect to math in general. See, you cannot put any value of X for which denominator becomes 0. Okay, right, you cannot put any value of X for which denominator becomes 0. Okay, the reason for that is anything by 0, right, or say any number by 0 is not defined. Okay, remember 1 by 0 is not infinity, it is not defined. Okay, 1 by 0 is not infinity, it is not defined. Okay, so any number by 0 is not defined. So if you put a certain value of X for which the denominator becomes 0, then the function won't be defined, your machine will not work. Okay, let's look at couple of examples here. Right, say f of X is 2 by X plus 1. Okay, say f of X is 2 by X plus 1. Now if we want to know what is the domain of X, we simply say X plus 1 cannot be 0, right, which simply tells you X cannot be minus 1. So you can put any value of X you want except for minus 1. You put 2, 3, 4, minus 10, minus 100, minus 20, you keep getting some answer. You cannot put minus 1. Okay, moving on. Similarly, another condition, now this condition comes because of our exam, right? This condition comes because of our exam, because in our exam complex numbers are not allowed, right? So second condition, okay, cannot put any value of X for which square root has a negative value. And we cannot put any values for which square root contains negative numbers. Why? Because with respect to our syllabus, square root of negative numbers, which are complex numbers, are not in syllabus, right? So again, say another example. Say we know g of x is under root x plus 1. Okay, g of x is square root of x plus 1. So to find the domain, you will say x plus 1 has to be greater than or equal to 0. Okay, x plus 1 has to be greater than or equal to 0. That means x has to be greater than or equal to minus 1. X has to be greater than or equal to minus 1. Okay, the idea is the value inside the square root has to be positive or 0. Alright, now if you understand this, let's do a mixture of both. Say for example, we have h of x defined as x plus 2 divided by root of x minus 1. Okay, and we have to find domain of x. So again, this numerator has nothing to do with the function. There are no conditions for numerator, right? It can be anything, but we know the denominator cannot be 0 and the value in the square root has to be greater than equal to 0. So what will we write? X minus 1, right? If you look at this condition, we are supposed to write x minus 1 greater than or equal to 0. Okay, but at the same time, because this is in denominator, I know x minus 1 cannot be 0, right? Because this is in the denominator, I also know x minus 1 cannot be 0, right? If you simply combine the two, right? If you simply combine the two, you can simply say x minus 1 is greater than 0, right? It cannot be equal to, so x minus 1 has to be greater than 0, which means x is greater than 1, which means x is simply greater than 1. Okay, so this is how we find domain of a function, right? Now questions on domain of a function will be either direct, wherein they will say find the domain of x, find the domain of y, or else they will be indirect, where they say given a situation, what cannot be value of x, what cannot be value of y, right? So when they say such questions, you will know that, oh, this is a domain question. Okay, now similarly, the way we learnt domain of a function, we learn range of a function. Okay, we try to figure out the range of a function. Now what is range of a function? Range is the output. Okay, what are the possible answers that you get? Okay, range of a function is simply a possible output. Okay, what are the answers that you get? Say for example, if we have f of x as x square minus 1. Now here domain can be anything because there is no denominator, no square root, right? So we say domain is all real numbers. Put any value you want, the function will always give you an answer, right? But now the question is range. What does range tell you? What will be the output? That means the answer that we get, what will that be? Okay, that gives us the range. Now to find range of a function, okay, we'll use a very simple method. What we will do is you replace f of x by y. Okay, you say let f of x be y. Any which ways when we draw the graph, f of x is any which ways your y axis. Okay, so y becomes x square minus 1. Okay, let's find x in terms of y. Okay, let's find x in terms of y. Okay, so you get x as root of y plus 1. Okay, you solve for it, you get x as root of y plus 1. Now whatever values y can take, that will be the output here, right? Whatever value y can take, right, that will be the output here, right? So essentially what we have is domain of y is simply range of function, right? The domain of y is simply the range of function. Now we know how to find domain. There is a square root here, there is no denominator, so y plus 1 has to be greater than equal to 0. That means y will be greater than equal to minus 1. Y will be greater than or equal to minus 1, right? So what will we say? That the range of the function, right, range is, right, any number greater than equal to minus 1. Okay, any number greater than or equal to minus 1. Okay, right, now if you want you can try this also. Let's plug and play, right? See, x square is always positive, so what is the minimum value of x square? 0, right? So if you put x as 0, the minimum value you get is minus 1. If you put x as 1, 0, 2, 3, 3, 8 and so on. So the values keep on increasing. The minimum value you are getting is minus 1. That is when x is 0. Otherwise whatever you are getting is more than that, right? So instead of observing and solving, it's better that you just follow this method and simply solve for it. Okay, now again this method works all the time, so it comes from the graph of the function. Okay, we don't need to go into the depth of that. Simply follow this, right? Simply follow this. What we did, replaced f of x by y, found x in terms of y, solved for y, right? Domain of y is range of x. Okay, now one interesting thing that you can learn from here itself, this, friends, is the inverse function. Okay, so inverse function of x is simply root of x plus 1. This here, right, also gives you the inverse function. Inverse function means reciprocal of it. Right, see, when we do what is inverse of 4, we say 1 by 4, right, because 4 times 1 by 4 is 1. Alright, moving on to the questions then. So see, we have machine's output follows the function, right? This looks like your sequence function, right? Where a sequence is provided, where n represents days. O5 is given to us, they are asking day 7, right? So O5 is given to us and they are asking us what is O7, right? O5 is given to us and they are asking us O7. So remember, whenever there is a sequence, what do? We plug in, obviously, but how do we plug in? Step by step, right? I know O5 is 15 and I know ON is ON minus 1 minus N. Okay, so the first step I do, since I already know O5 and I have to go up to O7, I find O6. So in place of N, right, in place of N, substitute 6, right, I get O6 minus 1 minus 6, that is O5 minus 6, which is, now O5 is 15, 15 minus 6, that's 9, but this is O6. Now I find O7, right, now I find O7. In place of N, I substitute 7, that's O7 minus 1 minus 7. If I solve that, that is O of 6 minus 7. 9 minus 7, answer is 2. Okay, so because if you see ON minus 1, ON is ON minus 1, you know this is a sequence function, no problem. Substitute values, but how do you substitute values? Go step by step, right? You don't have to waste time thinking what to do, how to do, just go step by step, you will end up with your answer. Okay. Next, so we have, for which of the following functions is p of minus 3 by 4 greater than p of 3? Okay, p of minus 3 by 4 is greater than p of 3. Okay, now again this is, see, we can't solve it normally because we don't know what the functions are, right? So it's a function question. Simplest way is plug in values, right? So what you do, just make a simple table. P of minus 3 by 4, P of 3, right? Let's go option by option. This is A option, right? For practice we are doing all of them, A, B, C, D and E. Okay, but in your exam, the moment you get the answer, you just stop there. Okay, so what do? For all the options, let's simply plug and solve. Let's find P of minus 3 by 4 in A option. So what is minus 3 by 4? 4 into minus 3 by 4 the whole square. Okay, if you solve it, that will be 9 by 4, right? Whereas P of 3 will be 4 into 3 square, 36. So clearly P of minus 3 by 4 is not greater than P of 3, right? Let's do the second one. This, you don't even have to solve, you will know minus 3 by 4 will be negative and for positive number it will be positive, right? See, minus 3 by 4 is minus 3, P of 3 is 12. What the point I was trying to make here is that, see, for a negative number the answer is any which way is negative, for a positive number the answer is any which way is positive. So how can negative be greater than positive? Okay, so you don't even need to solve for it. Okay, similarly, if you look at the third option, the 4 is common to both, right? 4 is common to both. The difference is the t square, right? Now for a fraction, t square will be smaller, but for an integer, t square will be greater. So again, you know, p of 3 is greater than p of minus 3 by 4. Okay, now comes fourth option. Okay, 4 plus 1 by t. Alright, so this is 4 plus 1 by minus 3 by 4. Right, if I solve it, it will become 4 minus 4 by 3. Right, if you solve, that's 8 by 3. Okay, this is 8 by 3. Right, there if I solve 4 plus 1 by t, 4 plus 1 by 3, right, that's 13 by 3. Okay, however, as I said before, you can apply the negative positive concept here also. See, you can apply the negative positive concept here as well. 4 is any which way is common. If this is negative, the value will decrease. If this is positive, the value will increase. So p of minus 3 by 4 cannot be greater than p of 3. Okay, now because we have solved all the 4 options, we know the fifth one is the answer, but let's just solve for it, right? Just to verify, it's 4 over t square, that's 4 over minus 3 by 4 the whole square. Okay, this is 64 by 9, this is 64 by 9, and here we have 4 over 3 square, that is 4 by 9. Clearly minus 64 by 9 is greater than 4 by 9. Okay, so even if you get questions like these, do not be worried, do not be scared of what to do, how. Just make a table, find p of minus 3 by 4 for each, find p of 3 for each, whichever is greater, like solve for each option. Okay, alright, moving on to the next one. So we have an expression, right? Whatever it is, represents remainder when a plus b is divided by a minus a. So we have a definition given here, right? What is it? A and this b is remainder when a plus b is divided by a minus b. Okay, no problem. What do we do? Plug in the values. You have two variables also and you have a definition also. Doesn't matter. Plug in the values in the variables in the definition, right, to solve the question. So what do we have here? We need 23 plus 11 plus 4 minus minus 23 plus 11 plus 4. Again, we apply BODMAS rule. We solve the brackets first. For this bracket, 23 becomes A, 11 becomes B. So this becomes remainder when 23 plus 11, that's 34, is divided by 23 minus 11, which is 12. Okay, remainder when 34 is divided by 12. If you solve it, this becomes 10, right? This becomes 10, right? Because 12 twos are 24, remainder is 10. Minus, again, we have to solve the bracket first, right? In order to solve this, that will be remainder when 11 plus 4, 15 is divided by 11 minus 4, that is 7, right? 15 divided by 7, remainder is 1, Okay, 15 divided by 7, remainder is 1. Now we solve the same thing again. This will become remainder 14 divided by 6 minus remainder 24 divided by 22. 14 divided by 6, remainder is 2, right? 14 divided by 6, remainder is 2. 24 divided by 22, again the remainder is 2, right? 2 minus 2, the answer is 0. Okay, so again multiple variables are given, no problem. Definition of a function is given, again no problem. All you have to do is plug in the values in place of the respective variables into the definition. Okay, you do that, you can easily solve the question. Okay. Again, a simple question. We have f of x as x square, g of x as x minus 4, g of f of x result in a prime number. Okay, so what are the functions? F of x is x square, g of x is x minus 4, right? We need to find g of f of x, right? We need to find g of f of x, right? So what do? Again we go inside out. What is f of x? Right? From here, what is f of x? That is g of x square, right? That becomes g of x square. How do we find g of x square? In place of x, substitute x square. So this is, right, g of x square is x square minus 4. So g of f of x is x square minus 4. Which of the following value will result in a prime number? Let's just plug and play. If I put 5, right, if I put 5, I get 21. If I put 4, I get 12. 2, 0. Minus 2 also 0. Minus 3, I get 5, which is a prime number. Okay. Moving on to the next one. Function models the symmetry. So f of x is f of 3 minus x, right? It's given to us that f of x is f of 3 minus x, and again which of the options will satisfy this. So see, it looks similar to a question we did just before, like a little while ago, when that said for which of the functions is f of p of minus 3 by 4 get greater than p of 3, right? But here they have given us a function. Does that make the question difficult? No, right? You remember what is it? Whenever a function is given, I can simply plug in values, right? So why don't you simply plug in? Say, what do you want the x value of x to be? Alright, say x is 1, fine, right? Say x is 1. So what does the question become? F of 1 is equal to f of 3 minus 1. F of 1 is f of 2. Correct? The question simply becomes, for which of the following functions is f of 1 equal to f of 2? How do we do that? Same. This is f of 1. This is f of 2. Right? These are my options. A, B, C, D, E. Right? Simply find f of 1 and f of 2 for each. Right? Whichever question, for whichever option they are equal, we get the answer. Right? For first one, what is f of 1? 4, right? 1 plus 3, which is 4. F of 2, right? That is 2 plus 3, which is 5. Okay, clearly not equal, right? Second one, 3 into 1 minus 1 square, that is 2. 3 into 2 minus 2 square, that is, 2. So B option it is. For B option, right, both the answers are same, right? Let's just continue. Find third, fourth, fifth also. 3 minus 1 is 2. 3 minus 2 is 1. Not same, right? 3 minus 1 whole square, which is 2 square, which is 4. 3 minus 2 whole square, which is 1 square, which is 1. X square, 1 square, 2 square. So it's only B for which it is same, right? So again, if a question like this comes, do not think how will I plug in, what will I do, don't try to think of complicated ways, right? Think of simple ways. We know if it is a function, it is applicable for all values. Plug in, right? Assume a value of x. If you don't want 1, try 2, 3, 4, whatever you want. Okay, try 2, 3, 4, whatever you want. Put x as 2, 3, 4, whatever, solve for it. See which option satisfies. Okay, now had I been solving this theoretically, right? If we were, say, solving this theoretically, right? Let's directly solve B option then. F of x is x common 3 minus x, right? So that is f of x. What will be f of 3 minus x? So in place of x, we have to substitute 3 minus x. So that will be 3 minus x bracket 3 minus 3 minus x, right? This is 3 minus x bracket 3 minus 3 plus x. 3 minus x into x, right? Now if you see, this and this are equal. It's right, it's product of the same two terms but in a reverse order. Okay, so again, no need to solve theoretically. Just assume x is 1, 2, 3, whatever you want. Make your table and see for which option are they same. Alright. Again, interesting question, looks difficult, right? But again, remember, it's a function question, it will be easy. We will just plug in. They say a smart thermostat rounds the temperature by the following function. This is the least integer greater than or equal to t. So again, a definition is given to us, right? What does this tell you? This is least integer greater than or equal to t. Okay, is means equal to, right? So is I am replacing by equal to. So this is the definition given to me. Okay, now the question says t by 3. T by 3 is equal to 5. Okay, t by 3 is equal to 5, right? And they are asking the range of t. So what does this tell me? See, the answer of this is the least integer greater than or equal to t. So answer of this, that is 5, is least integer greater than or equal to t by 3. Again, what did I do? In place of the definition, I just plugged in the values, right? The answer is least integer greater than equal to t. Answer here is 5. So 5, right? 5 is least integer greater than or equal to t by 3, right? Since 5 is greater than equal to 3 by 3, t by 3 can be more than 4 because it is least integer, right? So t by 3 can be 4.9, 4.8, 4.7, right? Integer, so it can go up to 4.1. T by 3 cannot be 4 because then the least integer will become 4 itself, right? So I know t by 3 has to be greater than 4 because 5 is the least integer which is greater than t by 3, right? If you draw your number line, right, this is 5, t by 3 is here before it, right? And this is the least integer. So t by 3 has to be above 4, right? Any value between this, correct? Just multiply by 3, 15, 12, right? So, right? Again, definition is given. Don't be scared. Put the values in the definition itself. Alright. This is similar to what we did just now. The function is greatest integer less than or equal to x. Okay. So what do we understand from the function? The function is greatest integer less than or equal to x. Okay. Again, I am replacing is by equal to. Okay, so the answer is greatest integer which is less than equal to x. Okay, and they are asking me, okay, there is a video game. Okay, let's score for each of the level. Let's find the score. Minus 2.3. What will I do? In place of the definition, in place of x, I just substitute. This will be equal to, again, greatest integer less than or equal to minus 2.3. So can you tell me what is the greatest integer less than or equal to minus 2.3? If you draw your number line, this is minus 2, this is minus 3, minus 2.3 will come here. So what is the greatest integer less than that? Or so this becomes minus 3, right? What did I do? In place of definition, plug in values. Okay, don't think, oh, what will be the function, what will I do? Definition is given, in place of definition just plug in values, right? Next, 4.1, right? This will become greatest integer less than equal to 4.1, that is 4, right? Similarly 2, for 2, right? Again, greatest integer less than or equal to 2, so equal to 2 is 2 itself, 3.9. Again, greatest integer less than or equal to 3.9, that is 3. So level 1 score is minus 3, level 2 is 4, level 3 is 2, level 4 is 3. What do they want? Total score. Total score will be 6. Okay. Alright. So what do we know? So bank is applying custom interest operation. B star is given as B plus B by 5. After two successive applications, after two successive applications, the account has 36 original amount. Alright. So first of all, let me just simplify. See, this B star is B plus B by 5. That is 6B by 5, right? And they are applying this operation two times. That means, let's see, if the original amount is X, right? Original amount is X. So what are they doing? X star and again applying it, whole star, right? X star, whole star. After doing this, the value is $36. Okay. So X star, whole star is $36. So again, this is just a character, treat it like a function. What will be value? We'll solve inside out. So what is X star from here? Right? Again, just put the value here. Right? So X star will become 6x by 5. The whole star is 36. Okay, 6x by 5, the whole star is 36. Again, how do I solve this? Again, in place of b, just put 6x by 5. Right? So that is 6 by 5 into 6x by 5 is equal to 36. Right? You solve this, x is 25. Right? X is 25. Very interesting question. Right? See, we have x hashtag y is given to us as xy square minus x minus y. Right? And they say x hashtag y is 2. Which of the following cannot be the value of y? You remember when I said, see, the question based on domain, they are asked in two ways. Either they say find the domain directly, or they say what cannot be the value of x, what cannot be the value of y. Right? Now, a common mistake that students make is they think, let me find the value of y. Okay? No, right? It's domain of y, correct? So the best thing to do is find x. Okay, isolate x. Find x in terms of y. All right. So do not solve for y. Instead, solve for x. Okay. What does that mean? That see x hashtag y is 2, right? Which is xy square minus x minus y. Solve for x because they are asking y. Solve for x. Okay, this is super important. What will you get? 2 plus y is x common, right? Y square minus 1. X is equal to 2 plus y divided by y square minus 1. Okay, 2 plus y divided by y square minus 1. Now what has happened? You have found a function in terms of y. Okay, you have found a function in terms of y. Now simply find domain of y. Right? Now simply find domain of y. What do we know about domain? There is no square root here, but there is a denominator. Denominator cannot be 0. So y square cannot be 1. Whenever we take square root of a variable, it is modulus. So mod y cannot be 1. Simplify it. Y cannot be, or plus minus y cannot be 1, or y cannot be plus minus 1. So y cannot be 1. Remember, the important point here is, if they ask which of the following cannot be y, solve for x, isolate x. Okay, so that you can make a function in terms of y. Okay. We have r is given as something, right, and they are changing the variables. By what factor does r change? Okay, so we know r is 6w square by 5xy square. Okay, now see, again students get confused. What should I do? Should I keep w as it is? This, see, remember, this 6 and 5 is not making any change, right? Previously also they were 6, now also you multiply by 6. So if you think, the change is coming only because of these variables, right? If you see, the change is coming only because of these variables. Okay, so let's focus only on delta r, that is the change in r. Let's not focus on what was the original value, what is the new value. Just focus on the change. 6 is not changing by anything, 5 is not changing by anything. Let's look at delta w square by delta x times delta y square. Okay, change in r is only coming because of respective changes here. W is changing by how much? It's becoming tripled, so 3 times, right? Square. X is halved, so half, and y is quadrupled. Quadrupled means 4 times. We solve this, that is 9 by 8, right? So your r is becoming multiplied by 9 by 8. Okay, again, it's a function. You don't have to think, okay, what is initial value of w this? Don't worry. They have asked change in r. Change in r will come because of change in w, x and y. 6 and 5 are same. They were multiplied to previous value also, now also. They don't bring in any change. Okay. Next one, so we have f of a plus b is given as f of a into f of b, right? F of a plus b is given as f of a times f of b. F of 5 is 4, we need f of minus 10. Again, you see it is a sequence based function. What do we do? Plug in values to get to that. Okay, what do? We simply plug in values to get to that, right? So what do I do first? Okay, I know 5, right? So one of the values can be 5. If I put another value as 5, I will get f of 10. But that doesn't lead me to anywhere, right? Because I want minus 10. So let me go in the opposite direction. So say a is 5, b is 0. I will get f of 5 plus 0 is f of 5 times f of 0. F of 5 plus 0 is essentially f of 5 is equal to f of 5 times f of 0. F of 5 you can either cancel, or if you want to replace, is 4. 4 is 4 times f of 0. You get f of 0 as 1. Right? We get f of 0 as 1. Alright, so now I have f of 0. What do? Let me get f of minus 5 now. Right? We'll go step by step. From 5 we got 0. Now we will get minus 5, then minus 10. Now what do? We have 5, we have 0. Let's figure out minus 5. Right? We have 5, we have 0. Let's figure out minus 5. So a is 5, b is minus 5. So we get f of 5 plus minus 5 is f of 5 into f of minus 5. In place of a, 5. In place of b, minus 5. We get f of 0 is f of 5 into f of minus 5. This we figured out is 1. F of 5 is given from the question as 4. F of minus 5. F of minus 5 is 1 by 4. Right? F of minus 5 is 1 by 4. So see, we found f of 0. Then we found f of minus 5. Now we find minus 10. How do we do that? Correct. Right, what do? A is minus 5, b is also minus 5. Right, a is minus 5, b is also minus 5. We get f of minus 5 is f of minus 5 into f of minus 5. F of minus 10 is f of minus 5 is 1 by 4 into 1 by 4, that is 1 by 16, right? So again guys, the point is, do not be worried about how the function is given. Remember, all you have to do is simply plug in values to solve all the question. Okay? I hope you were able to understand the concept of functions and custom characters. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.